All right. So, okay. So basically what we're going to do today is we are going to start spread H, or we are going to finish spread H, I should say. So if you guys remember when we were in class last week, we went through the basics to begin with. So we looked at what is the difference between a sample and a population. We said the sample are the specific group of people who take part in the study, whereas the population is the larger or broader group from which the sample is taken. Okay, and in terms of the population, not everyone in the population will take part in the study. It's only that specific small group of people, or the small purple rectangle, small purple triangle, that is the sample. Okay, so that's basically the difference between the two. Then we looked at the difference between the two variables that we often use in experiments. So IV and DV, we said the IV is the cause. Okay, it's the cause factor. The DV is the effect factor. So the effect of red cordial on hyperactivity. So hyperactivity is the effect, that's the behavior we're measuring for change. And red cordial is the IV, that's basically the cause. That's what we're expecting to cause some change in the behavior. Okay, and we said that the independent variable is independent of, it's separate to the DV, but the DV is always kind of dependent. That's why it's called the dependent variable, because it's dependent on the actual IV to make an effect there. Okay, so basically when we're looking at operationalizing the IV and DV, what that means is that we are looking at how the IV and the DV are measured. Okay, so when we're operationalizing the IV and DV, we're basically putting a quantity to the IV and DV. We're basically deciding, okay, how much of a specific thing are we giving? So are we giving 300 milliliters of Coke? Are we giving 400 milliliters of Coke? So remember when I gave you guys that example, I said I can give my participants like 1 liter of Coke if I want to. And that would be me, that would be how I'm operationalizing the variable. It's just putting a quantity or a specific measurement to that variable that I'm measuring. Then we talked about research hypothesis. We said that a research hypothesis is a testable prediction. It's literally just a prediction or an estimation, or basically our kind of like how we foresee something happening. So our prediction of something, of how one factor will influence another factor. So when we write a research hypothesis, we said we need to include these 4 elements. We abbreviate them using the word iPod. In class, I said we can actually add a C to this and call it iPod C. So iPod C, okay? And the C stands for, does anyone remember? It's control group, okay? So control group. And we said that without the control group, there is no experiment. So the control group is really important for us to run the experiment, okay? So just remember, and we did an example of a research hypothesis in class as well. In the actual test and exam, you will be asked to write research hypotheses. So it's not rocket science. You just need to remember the structure, and just remember that you're simply writing how one variable, which is the IV, is going to affect another variable, which is the DV, okay? We also talked about what an experiment is, and I'm not going to go through this slide too much because we all know this. You guys have been learning this from year 8 or year 9. An experiment is literally just a study or a research investigation that's conducted under controlled conditions. What controlled conditions means is usually we conduct experiments in conditions that are not variable, in conditions that are not unpredictable, usually in like a lab or a research kind of industrial area kind of thing, where it's basically controlled, okay? And experiments are always assessing a cause-effect relationship between 2 variables. Those variables are usually the IV and the DV. And we said that the cause in cause-effect represents the IV, the effect in cause-effect represents the DV, okay? That's the basic idea. Okay, and I think we finished off talking about the experimental group and control group. So experimental group is the group that's exposed to the IV. The control group is not exposed to the IV, but we still need them and we still use them as a basis for comparison. So basically we look at them as a baseline for comparison. So if I talked about the people in the class who drank the Coke, as part of that example we were talking about in class, that's the experimental group, because in that example, the Coke was the IV, okay? The control group would be the group that would just drink plain water or would drink anything but Coke, because they're the group that we have to use as a basis for comparison to see whether the Coke actually had any effect on the actual participants in the experimental group. So they're simply used as a baseline for comparison. Okay. Okay, so today we're starting with a few new topics, and we shouldn't take too long because most of these topics are quite straightforward. You would have heard of some of the terms in lower year levels as well. So the first thing we're looking is unwanted variables. So in the previous class, when we talked about variables, we talked about the fact that there was an IV and there was a DV. Okay, and we talked about the fact that the IV would almost always or should almost always cause a change in the DV. Now, what happens is, although it's easy for us to say, yeah, the IV causes a change in the DV, our experiment is done, full stop, everything is all good. The only problem is that unwanted variables can actually come in the way of the IV and DV. So I'm just going to say unwanted here, okay? So in between the IV trying to make a reliable change on the DV, an unwanted variable can step in. And last class, I kind of got you guys to brainstorm as well about what are the other factors that can affect someone's concentration. Because remember, the example that we talked about in class last time was, if I can type, it was, I think, the effect of drinking Coke on concentration levels. Okay, so that was the basic experiment or basic example that we did. So basically, when we looked at that, we were talking about the fact that there are other factors other than the IV that can affect the DV. So other than drinking Coke, there are other factors that can affect your concentration level. So then at the end of our study, how can I make the deduction, or how can I come to the conclusion that, yes, for example, yes, Taha has gotten 92% on his test and he has good concentration because he drank Coke. Maybe it's that Taha wanted to, maybe it's that he studied really hard for the test. Maybe it's that he, was paying a lot of attention in class that day. It might not necessarily have been the Coke that had the actual effect, okay? Or conversely, if someone else, for example, if Hafsa doesn't do well on the test, I can't say that that's because of the Coke. That might be because she wasn't paying attention in class. That might be because she wasn't feeling well, she wasn't in the mood to do the test. So you can see that there are so many other factors other than the IV that can affect our DV in any experiment, not just that example, but in any experiment. We call these unwanted variables because unlike the IV directly affecting the DV, unwanted variables make it difficult for us to produce reliable results. So that's the main issue. It becomes difficult to get reliable results. And obviously in any experiment, you would realize how important it is to get reliable results. So reliable results are not something that we can get if we have too many unwanted variables. Now, coming to the two words that are on the screen now that you probably maybe have heard of, maybe haven't heard of, extraneous and potential confounding. So extraneous variables and potential confounding variables are just two types of unwanted variables. They're the names that we give to the unwanted variables in a study. Now, an extraneous variable is any outside influence that can affect the DV. It's usually an external factor, and usually, but not always, it is an environmental variable. What that means is if I get you guys to do a test and I'm using that test as a basis to judge how well you concentrated or how well you can concentrate, if the lights are not on in the room, or if there's too much noise coming from the other classroom, or it's too hot and the air conditioner is broken, those are other factors other than the Coca-Cola drinking that will affect your ability to do the test, okay? Obviously, when it's too hot in a classroom, students can't concentrate. They're sweating, it's hard. If the light is not on, there's not enough light. Some students might not be able to see the test questions very, very well. If there are too much noise coming from the next class or from outside, you get distracted. So your concentration is affected as a result of that. So those are all extraneous variables, okay? Potential confounding variables are different though. With extraneous variables, if I realize there's a lot of noise happening, or if I realize the lights are off, or if I realize that it's really hot in the classroom, I can just say, okay, everyone get up, let's move to another classroom. So I've got some control over that variable. I can basically fix it at the beginning before it actually has any negative effect on your actual results. With potential confounding variables, we call this the sneaky variable. Not only is it unwanted, but it almost always succeeds in terms of actually affecting the results in an unwanted way. Unlike the extraneous variable, I cannot control the potential confounding variable. So the potential confounding variable often does slip through and does go on to confound the DV. What does confound the DV mean? DV is a fancy way of saying results of the study. Confound the DV means that I affect the DV in an unwanted way, that it makes it difficult for me to determine, was it the actual IV, the drinking Coke, or was it some other variable that has affected my final results? Okay, so that's basically what unwanted variables are, and an introduction into unwanted variables. And the question, is that what makes the outlier? Yes, correct. So when we have outliers in a study or in a set of results, outliers are unexpected results. So if everyone's getting like 80s in a sack and somebody gets like 10%, that's an outlier. That's like a very strange or unusual result. That could have been the result of an unwanted variable or influenced by an unwanted variable. So there, yeah, that's correct. Unwanted variables like extraneous and potential confounding do influence the appearance of outliers or unusual results. That's correct. Okay, so I think there's more examples on the next slide. These are some more examples, just showing you, if I'm doing, for example, a study on, what was the study? Let me just see what this one says. Poor sleep on driving ability. Okay, so we'll just stick to the specific example on the slide. So poor sleep on driving ability. Now, obviously in this case, what do you guys think the IV would be? Just put it in the chat box. Okay, so hopefully you guys were able to identify that the IV would be poor sleep and the DV would be driving ability. And I'll tell you why. Driving ability here is what we're measuring for change. It's kind of the behavior or the phenomenon that we're measuring for change. Poor sleep, on the other hand, is the phenomena that we are manipulating. Okay, it's what we're basically changing in the experiment to cause some effect or to have some effect on the DV. So poor sleep obviously can affect driving ability, but it's not the only factor that affects driving ability. So for example, if we brainstorm all the factors that could possibly affect driving ability, if we just open up a little text box somewhere here, and we say, okay, what are the other factors? If you've got any in your head, anything that you think can affect a person's driving ability, just put it in the chat box and we'll include that as well. So just off the top of like just thinking about what other factors affect driving ability, you know, we can talk about like your age, okay, what license level you're on, okay, whether you're L's, whether you're P's, whether you had a full license for many years. Okay, within P's, you can even talk about whether you're a red P or whether you're a green P, okay? So that also has an effect. In terms of driving ability, we can also talk about, you know, the familiarity you have with the driving area. Okay, so I might, for example, maybe be more comfortable to drive in my own suburb. And I might make less mistakes driving in my own suburb compared to a brand new suburb or even a brand new state in Australia. Okay, so familiarity with area you're driving in. What else could we talk about? We could also talk about what other factors other than, we can talk about weather conditions. So that's what we see in the picture here. Even the best of drivers, when it's rainy or when it's foggy or when there's a lot of thunder, they might not drive as well as they normally do. You could talk about distractions in the car. If there's a lot of noise in the car or there's a lot of commotion happening outside on the road, you might get distracted. So distractions in the car or on the road outside. Okay. So that can obviously affect your driving ability as well. So all of these are, a common thing between these is unwanted factors other than the IV that can affect the DV. That is, can affect driving ability. Okay, that's the basic idea we're talking about here. These are all factors other than poor sleep that can negatively affect someone's driving ability. And for this reason, all of these can be considered to be unwanted variables, so extraneous or potential confounding variables. Okay, so that's important for us to understand. Yes, that's a really good one. Yeah, another really good one I just read in the chat now, alcohol levels. Yeah. So some people do drink and drive. So whether you've drunk alcohol before you've gone driving, whether you've taken drugs before going driving, some people even drive better with caffeine because it stimulates their brain and makes them concentrate better. So again, intake of any substance of that kind can also influence your driving ability. Yeah, excellent. So that's basically extraneous and potential confounding variables. Now, usually in SAC and exam situation, what we do is we just give you a scenario, and then you, just like what we did right now, you just need to brainstorm what are the factors other than the IV that could potentially affect that DV. So to do that, first of all, you need to identify what the IV and DV are in that study, and then brainstorm all the factors other than that IV. So in this case, other than poor sleep, that can affect the DV, which in this case was driving ability. Okay, it's not such a hard skill, but if you can get it down pat and understand it from now, if you are going to do any of the sciences, not just psychology, any of your sciences in BCE, will make your life easier, because this is a topic that does come up across the board. Okay. Again, it is related to research methods and your key science skills. So continuing on, that was basically unwanted variables. So now we're finished with the unwanted variables, extraneous and potential confounding. Now we're looking at the sampling techniques. So convenience sampling is the main one that we're going to look at today, mainly because convenience sampling is the main, not main one that's used, but it's most common. And I'll tell you why it's most common. First of all, I want you to understand that sampling basically means selecting. How are we selecting participants? How are we choosing participants for our study? So that's basically what sampling is about. So convenience sampling is a sampling procedure or a way of selecting participants where participants are based on how easy they are to access for the researcher. So as a researcher, for example, if I'm a researcher and I want to do a study, I might select you guys to be my participants because I see you guys like 5 times a week, so 5 periods a week. I see you guys at school, and it's easy for me to just use you guys as my participants because I don't have to go outside of school and, you know, actually recruit people. I can just use you guys because I see you. Okay, so that is one way that convenience sampling can happen. So you need to remember that.
Is that also for the one that we watched the video where they electrocuted shocks? Is that how they did this as well? Because it said something around that.
Yes. Yeah. So again, anytime that participants are volunteering for a study, that's convenient sampling as well. So yeah, that's a really good point. Anytime participants are volunteering, so I think that's the third point here. Whenever you see the word volunteered in a case study or in a scenario, in any question, that's basically just talking about convenient sampling. So that's a really good clue for you to realize that convenient sampling has been used. If your teacher asks you to join a class experiment, if your coordinators come around and ask you to take part in an experiment, all of that is convenient sampling. And sometimes, especially if your teachers or someone that's in a higher authority than you asks you to take part in an experiment, you might not necessarily want to take part, but because they're asking you, you often say yes. Again, that's why even though convenient sampling is called convenient sampling, it's not really convenient for the participants. It's more convenient for the experimenter or the researcher, okay? Again, we'll talk about ethical principles if you continue to do psych next year. Okay, so yeah, that's convenient sampling. And both of these diagrams, this diagram and this diagram, show you that it's about choosing people who are close to you. So if the researcher, for example, is this person here, they're choosing the people that are closest to them, the people that are easiest for them to access, the people that are convenient for them to access. Just be careful with this terminology because it's convenience with an E-N-C-E, not convenient. Okay, so this is, I know it sounds pedantic, but this is how they mark it in BCE. So when you're writing this word in your SAC, if you write convenient sampling, that is going to get you 0 marks because that's not correct terminology. So it should be convenience sampling, okay, with the E-N-C-E. That's important. I know that sounds pedantic, but that's how they mark at BCE level. That's not how teachers mark. I mean, that is how we mark, but that's how the BCE examiners mark as well. Okay, so we need to drill these habits into you early on. Okay. Another question. Yes, we do have a SAC. So as part of this, as part of your upcoming test, sorry, on Tuesday with the social psychology, research methods will be included in that as well. That'll be on Tuesday. So Tuesday, period 6. Yeah, same time next week. Okay, so convenient sampling is really easy and amazing, but the only problem is you're only choosing people who are close to you. You're not making it so that every person in the population has an equal chance of being selected. Now that sounds really confusing, but it's not. I'll explain what that means. That basically means that we haven't made an attempt to randomize participants. We haven't made an attempt to ensure that every member of the population has an equal chance of being selected. If I say, okay, I want my year 10 class to be the participants for my study, because you guys are close to me and it's easy for me to use you guys as for my experiment. I'm using you, obviously, I'm selecting you as my participants, but that means that I'm not allowing the other year 10 science classes to be involved. So basically, I'm shutting them off and only using you guys. So it's not fair in the sense that yes, it's easy for me to carry it out and it's easy for me to get participants, but the problem is that not every member of the population of year 10 science students had an equal chance to be in my study, because I just decided, yep, it's my students, it's my class, that's it, we're done. Okay, so not every other year 10 science student had an equal chance to be selected. Okay, so for that reason, we say the sample is a non-representative sample because it doesn't represent, your results will not represent the complete results of the rest of the students because they never had a chance to be involved in the first place. Okay, that's the basic idea. So that's convenient sampling. Then we look at experimental design. So experimental designs are the ways in which we organize participants. Okay, so sampling was about selecting participants. After you've selected your participants, how do you now organize participants? Okay, across the two groups. So across the two groups. And if you remember correctly, our two groups were the experimental group. That's the group that gets exposed to the IV, and the control group. Okay, so how we organize participants, don't forget that. Now, a little shortcut that I can probably tell you guys is, although these three slides explain in detail what the three designs are, if you are feeling really, really lazy or you're really stretched for time, at least know this slide. This slide summarizes the whole three designs and tells you what the three designs are about. And that is basically what you need to know anyway. But yeah, it is important for you, more than the definitions of these three designs, you need to be able to spot when these designs are being used. So if I give you a scenario or an example of a research study, you should be able to say, yep, this is an independent groups design, or yep, this is a match participants. Okay, so in order to do that, we need to have a basic idea of what each design looks like, okay? How it looks like when we organize participants according to each of these three designs. The first design is called the independent groups design. Independent groups means that each group is independent of one another. Now, independent groups design, it sounds like independent variable, but it doesn't have anything to do with independent variable, okay? So don't get the two confused. Independent groups design basically suggests that there are two clear groups, and those two clear groups are independent of one another. Independent means that the two groups each have a different person in them. Okay, as you can see in this diagram here, person A, person B, person C. Oh, I should use a different color. Okay, sorry. Person A, person B, C, D, and E are different from person F, G, H, I, and J. We're not using the same participant twice. Okay, it's the same. Sorry, it's not the same people that are being used. Okay, it's completely two different groups of people. So if you read a research scenario and it looks like two separate groups are being used, and it's not like one person is being used for both the experimental group and then the control group as well, then that's a surefire way that you would know that that's an independent groups design. Okay, you need to know one advantage and disadvantage. So one advantage of independent groups design is it's the easiest group to put together. You're literally just getting a bunch of different people, dividing them into two groups. That's it, your job is done. So it's very easy and completely can be done completely quickly. But the only problem is that because you're using different people, you are increasing the level of individual participant differences. Although differences are good, differences also increase the likelihood of extraneous and potential confounding variables coming up. Okay, so that's the disadvantage. So that's the independent groups design. Okay, there's a clear experimental and control group, and each person is different. We're not using one participant twice. Each participant is different. Now, hold on to that thought. as we go to look at the repeated measures design, because the repeated measures design is the complete opposite of the independent groups design. What that means is that in the repeated measures design, rather than using different participants, we're actually reusing the same participant twice. So if you have a look at the previous slide had this sign, not equal to, but this slide actually has an equal to sign because person A, maybe we'll call him Ben. Ben is literally going through the experimental condition, and then that same Ben is going through the control condition. He participates in the experimental group and then later also participates in the control group. So all these people, person A is person A here, person B is person B here, and so on and so forth. They're the exact identical same person being reused across both conditions. Okay, so reused. That's why it's called repeated measures design, because the participant repeats the experimental condition and then they repeat the control condition. They're used repeatedly or more than once. Okay, so the repeated measures design is when one participant is exposed to both the experimental and control conditions of the study. And basically they form both the experimental group and the control group. And a question, won't they already know what's going to happen? Yes, that is one of the disadvantages of repeated measures design. They don't really know what's going to happen, but because they already went through the experimental condition, they know what the other group is going to do or has done because they were the other group. So their expectations can actually influence the results in an unwanted way sometimes. Also, another disadvantage is order effects. When you're the same person doing the same tasks in the experimental group and then doing the same and then doing something in the control group again, going through the trials or the groups again and again can actually lead to you either getting bored, either getting tired, or if you're motivated, you actually get better. Okay, so you actually get better at doing something. That's what the order effect is. And order effects only happen in repeated measures design, where there's a repetition or a reusing of that participant. Okay. And again, like you said, because that same participant is being used for both the experimental and control condition, that can lead to unwanted participant expectations because they already have an understanding of what has happened. And so they use that understanding to form an unwanted expectation of what they think is going to happen. Okay, repeated measures design is good or advantage in the sense that there are less individual participant differences. It's the same participant going through both conditions. So obviously, there's not going to be many differences there because it's the same person that we're using twice. So that's the repeated measures design. The match participants design is when we try to match participants on certain characteristics or qualities, again, to just ensure a reduction in individual participant differences. Now, this is good because obviously when we have lower individual participant differences, there are less chances of potential confounding variables taking place or the results getting affected in an unwanted way. A disadvantage is that although it's easy for me to say, oh yeah, this girl has an IQ of 120, I can find a girl that's just like her in every other way with an IQ of 120 as well. It's easier said than done. So it's very time consuming and very costly to actually recruit participants and find participants who are matching in terms of similar characteristics, okay? Because we're not talking about using identical twins here, guys. We're talking about using a different person who's got the same qualities as you. So in the case of my study, if I don't want the individual's own study habits to affect their ability on the test, if I want only the Coca-Cola to affect their ability to concentrate in the test, I would have to look at two students who always get between 80 to 85% SAC averages or something like that, like similar levels of motivation, similar levels of academic ability, which is actually quite hard to do, okay, because everyone is different. So again, very time consuming and costly. That's the negative. The positives are that we are reducing individual participant differences. So guys, one thing that you can do is that the advantage for both the repeated measures and matched participants is exactly the same. It's that we're reducing individual participant differences, okay? So that's one thing you don't have to, I guess, relearn again. Okay, so those are our three designs. So just know what they are. So if you are given a scenario, and we'll look at a scenario tomorrow as a practice, you know which design is being used in that scenario. Okay, we're coming to the end. So conclusions and generalizations. You guys have done conclusions, I think, in all your prac reports. You know what a conclusion is, or you should know that it's about a decision that's made. It's a simple statement that's discussed, or it's a simple statement that's identified about what the results mean. So usually if you're doing a confusing experiment, it's actually better for you to write a really clear conclusion. So even a layperson, even someone who's not familiar with your scientific experiment that you've done, can still understand what your results mean. They can still understand what you got out of your results. A conclusion is kind of like, you know, when we talk about something and then we bring it back to this basic idea, like, okay, at the end of the day, guys, this is what I'm trying to say. The conclusion is literally the end of the day, guys, this is what I'm trying to say. That is the concluding statement or concluding sentence that you use in a study. It's always based on the result. It's always based on the evidence or the experimental findings. It's not just an opinion. It is a educated decision that you make based on the results that you achieve. Okay. Yes, and a generalization obviously cannot always be made, but depending on the conclusion that's made, particularly if your results did end up supporting your hypothesis, you can make a generalization as well. A generalization is about how we can apply the results of our study to the broader population. So if I do a study with you guys in class, can I then apply those results to the rest of the year 10 science students, or even more broadly to the whole year 10 cohort in general? Okay, can I do that? Obviously, if I use convenient sampling, a generalization is automatically something I cannot do, okay? Because I can only make generalizations when my sample is representative to begin with. That is, when my sample was randomly selected, or that when everyone had an equal chance of being selected, rather than me just saying, okay, yep, it's my class that's going to take part. I needed to give everyone an equal chance to be selected. And if I didn't, then a generalization simply cannot be made. Okay. Now, a number of factors can affect generalizability of results, but honestly, at year 10 level, we are not going to go that in depth. Okay. But the number of factors are things like having more boys than girls in a study, or vice versa. Having participants who are just taking part in the study to get a reward that the teacher or experimenter has promised. Participants who are very different and who bring individual participant differences as unwanted variables to the study, etc., etc. Or if there's any ethical breaches. So something like the Stanford prison experiment, Zimbardo was not able to generalize those results back to the broader population simply because there were way too many ethical breaches involved, and also because he did use convenient sampling as well. All right, that's it. So we're literally just done for today. These two slides are about the reporting conventions, talking about referencing, so how you reference results. Next week, we will do a little research poster based on a scenario. We'll talk more about that when we get to school next week, but we will be doing a practice research scenario tomorrow. So please make sure you attend our live session tomorrow at 11 a.m, period 3, and we'll go through that together, and we'll really explain it so you guys know it really well. They're not as hard as you think. They're pretty straightforward. We'll just do it step by step. Okay, I'm going to stop the recording here.